keep the ball rolling along, we're going to turn it over to Dr. Bill Cohen, the Chief Technology Officer of the Army. Going to have a very interesting conversation about next generation combat vehicles with Major General Ross Coffman and Brigadier General Glenn Dean. I'm going to do their bios really quickly, and then we'll turn it over to them. So Dr. William Bill Cohen serves as the Chief Technology Officer and Principal Advisor to the Assistant Secretary of the Army for Acquisition, Logistics, and Technology. His office provides technical insight, independent analysis, and demonstrations to show solutions and approaches to accelerate the adoption of appropriate technologies, frameworks, and architectures that contribute to Army dominance today and in the future. Major General Ross Coffman serves as the Director of the Army Futures Command Next Gen Combat Vehicles Cross-Functional Team. The NGCV-CFT is the group tasked with meeting the Army's demands for modern vehicle capabilities, from sensing and processing data to moving around in different physical and virtual terrain. Experienced director with a demonstrated history working in the military industry, offering 29 years of management, leading units of up to 29,000 personnel with millions of dollars in assets and funds. And then Brigadier General Glenn Dean is the Program Executive Officer for Ground Combat Systems at U.S. Army. He was commissioned as a U.S. Army Armor Officer in 1993 as a distinguished military graduate of the ROTC program at the Florida Institute of Technology. His first assignment was the 2nd Battalion, 69th Armor at Fort Benning, Georgia, where he served as a tank platoon leader, scout platoon leader, and company executive officer. Prior to ASALT, Dean worked as a project manager for the Stryker Brigade Combat Team. He also served at the Tank Automotive Research and Development and Engineering Center as military deputy and supported the Bradley and Armored Knight program as product manager. Brigadier General Dean assumed the role of the Deputy for Acquisition Systems Management in July of 2019. He assumed responsibility for the Program Executive Officer Ground Bout Combat Systems in December of 2020. I cannot think of any group, a three-person group, to talk more authoritatively about next-gen combat vehicles, and we look forward to your all's discussion.
Since the end of the Cold War 30 years ago, we have been beset by a rapidly evolving threat environment. We have been paced and, in some cases, overtaken by our peers and near peers in multiple overlapping and at times competing mission requirements. Counterinsurgency was just the bow wave as our adversaries took their time to work inside our strategy. This not only requires the Army, but its associated industrial base to adapt now. We use our equipment for decades, and it is imperative that we can efficiently and consistently upgrade to new and evolving threats. Given the current period of tight technological competition, it is very important to calibrate the way and timing which we roll out such innovation. The relationship between the Army and the industrial base must continue to evolve with a sort of always in beta mindset and away from, in some cases, a POM or a block upgrade mindset. This involves rethinking the risk tolerance that industry and its government customers are accustomed to accepting. This involves reassessing how we engage the commercial sector in prime and subprime relationships. Most of all, it involves having a clear understanding of our technology supply chain down to the 3rd and 4th tier. By doing so, we stand a chance of going to war with the Army we want and the equipment we want. I realize there's a few things to unpack here, but I hope it'll serve as a starter to a robust discussion. I'd like to start that first question by asking General Coffman and General Dean, how is it that the CFT and the PEO came to be co-located in Warren, Michigan? And how has that helped you to achieve what you're trying to do with developing the next generation technology for the Army?
Yeah, thanks so much. It's a great story. So when Army Futures Command was designed, the then Undersecretary of the Army, the FCC Director, and I think the Vice Chief of Staff of the Army toured the country looking for where they were going to put the headquarters of new Army Futures Command. They settled on Austin, Texas. And all their 1- and 2-star cross-functional team leads, they wanted to put in the epicenter of innovation for that particular field. So in Huntsville, with all the space focus down there, we put our aviation asset, our CFT there. For us, I mean, Glenn and I, we're we're tankers, okay? We're armored vehicles. We got engines and smoke and things that go boom. And where better to position us than right here in Motown, Detroit Rock City. And Glenn beat me here, right? It's like I wasn't born in Detroit, but I got here as fast as I could. Bumper sticker for me. But when you got not only Glenn, but you got contracting, you've got the science and technology, all the industry partners. It just made sense for us to be here. And Glenn, I'll let you expand on why that's beneficial.
Yeah, so our real anchor here is the one member of our team that's not represented, which is the Ground Vehicle Systems Center, right? So of course we've been doing combat vehicle development in Detroit since they built the Detroit tank plant back in the early 1940s. And that was here because the auto industry was here, and this was the arsenal of democracy. And it has continued to be. And we don't have a tank plant here anymore, but our prime contractors, a lot of the downstream suppliers are all here, and they share this industrial base of suppliers and engineers. And there's a lot of intellectual movement back and forth between the government, really on the engineering side with our Ground Vehicle Systems Center, and industry. And that keeps this kind of the center of the combat vehicle universe. And so it's really the best place for us to collaborate. It's really great to have our user partner here with the CFT, because they can see the technology firsthand. They can use it to drive experimentation. When they're doing soldier touch points, right, they're working with the lab and field units, and the center of what they need to display is right here, easy to reach out and touch it and reach out to industry's innovation. So it's really a great place to be.
But the other thing is weird, like right down the hall from my office, 12 steps is the OMF VPM, right? And so if he's got a question, he doesn't have to call to Fort Benning, Georgia. He just walks down the hall. If Glenn is, got something for me, he just walks down the hall. Where you stand is where you sit. And I'm sure glad I'm sitting in Detroit, Michigan.
Thanks. How does the Army view MOSA as a strategy for developing its ground combat vehicles? You want to start with that, General Dean?
Yeah, so MOSA, Modular Open Systems Architecture. It is the foundation of all our future modernization. So it'll take you back to how we developed vehicles before we started digital. You had all these mechanical components, and you were paced in adding capability by the speed at which you could develop a mechanical component, get it to interface with all the other things you've done. And it took quite a bit of know-how and knowledge, and you had to have all the specific technical drawings or nothing would match up. Add a digital layer to that, so we started computerizing our armored vehicles really in the 60s with early fire control, but true digital computing came in the 90s. And at the time we were trying to do open systems architecture, and we decided, hey, wouldn't it be great if everybody developed based on the same computing language? So we came up with this thing called ADA. Well, nobody uses ADA today except isolated pockets of the DoD, to include one here in Detroit, Michigan. But the intent was good, which is, hey, have a standard that everybody can refer to and build on so you can get maximum innovation. So what we're driving to is really two parts: modular, so be able to upgrade in smaller pieces and bring smaller components and ensure that is spread to the widest number of people. And then the second, open, commonly used standards, right? Where we can, not something unique to the Department of Defense. If it's an industry standard, right? Think USB, start there first, and then only adapt to defense specific where you have no other choice. Again, to allow the maximum innovation. And so it's sort of like, to use a cell phone analogy, not iPhone, but Android, where the government needs to control some interfaces, but we can allow multiple hardware producers to produce our phone and multiple folks to build apps to reside on our phone. And we just want to make sure that the two be able to work together. In this case, we're not going to own the software, so we're not quite Google. We're not going to own Android, but we will control the interfaces where they interact. And MOSA is a bridge to another term you may have heard the Army use, SAMOA, or Common Modular Open Architecture. And that commonality is driving in two directions. One, that we're common across multiple portfolios. So as we're developing the architecture template that we're using for our future vehicles, we're working with our counterparts at the C5ISR Center, at the Aviation and Missile Center down in Huntsville, PO Aviation, to adopt some of the things that are in their architectures, so that somebody who's developing maybe an aviation system may have that compatible with something that's on a ground system, which opens up more opportunities for innovation. And then the second, so that's cross-portfolio commonality. And then there's the potential for cross-system commonality. The fire control in a Bradley fighting vehicle, fire control in an Abrams tank, the fire control in an optionally manned fighting vehicle, their functions are fundamentally the same. Today, Bradley and Abrams are architected completely differently, though. And so I can't take one component and easily use it for both once the base system's been developed. The view in the future is, hey, my OMFV and maybe what comes next, an optionally manned tank, for example, or an optionally manned howitzer. I should be able to spill components across those using MOSA. And so the opportunity, if I'm an innovator in industry, once I bring a MOSA compliant device, is that not only do I have the potential to apply it to the system that's currently developed, but I may be able to now use that across multiple systems. So it opens up more opportunities. And for our systems integrators, our prime contractors or OEMs that bring the vehicle together, that gives them a broader choice of subsystems to draw from with a greater potential for maturity and innovation. So we think this is the way of the future. Again, the government's piece in this is kind of in the middle of publish a standard, publish a set of interfaces and controls to allow things to interoperate, but then allow industry to provide the innovation.
That's a great answer. General Coffman, you're on mute.
My microphone is not MOSA compliant. All right, so as a requirements generator, this opens up an entire portfolio of things that can go on the future vehicles or on our legacy vehicles. And because of the work that Glenn and his team are going to do on MOSA compliant, now when the best widget in the world is out there, years after a vehicle is produced, all we have to tell them is, as long as you're MOSA compliant, as long as you are compliant, then you can participate. And the Army can procure that and not have to pay the OEM that generated the software for that vehicle an exorbitant fee. It's plug and play. And so it just absolutely offers many, many options to me as a requirements developer.
So General Dean, industry might ask, well, how am I going to keep making money doing that? Does it open up new spaces for industry?
Yeah, I think it gives them more customers. Again, more platforms, as opposed to, hey, I'm bidding on Bradley Mark II, and that's done. I've got on that upgrade, but that system, which is what happens today. Great, I'm the fire control unit on Bradley. It does me no good. I can't go anywhere else. To okay, now I'm on the MOSA fire control on OMFV, and I can be on the next MOSA compliant system right beside that. It really should open up more opportunities. And again, on the system integrator side, more room for innovation. The potential growth for us then in capability is that once those architecture and interfaces are understood, and we're talking about largely digitized platforms, even though we've done some limited digitization on the platforms we have today. I mean, the Abrams tank today is a digital vehicle, but not in the way that we're envisioning for the future. And that means I can bring a lot of technology and capability to the platform that's purely software resident. And so I can, like uploading a new app, I can bring on a new capability because it's MOSA compliant, it's able to be resident on the computing systems that we've built into a platform, and it's able to communicate with the other computing systems that are on that platform through the architectures we've established. So more hardware vendors, a lot more software vendors, a lot more people who can enter the space to bring us combat vehicle capability that traditionally have not been.
At the end of the day, no matter what we design, there's always going to be an E3, E4, E5, et cetera, operating that system. How do you ensure that the technology doesn't outpace the training that we give our soldiers to operate these vehicles?
Yeah, well, I think the entire process is it's just fascinating. The Army's got a system for everything, biggest bureaucracy in the world. But it really starts about 7 years out from fielding the first unit. So we start backwards planning. So when you got to write the manuals, when you have to assign the new instructors to the schoolhouse, when you need to have the schoolhouse's training set. But in the Army, something we do very well and is called new equipment training. So when someone gets a new piece of equipment, then that new equipment starts to be trained into the schoolhouse. So when people enter the Army and go to the schoolhouse, and also at the unit that's receiving it. So they show them how to shoot it, and they show it how to maintain it, and they how to operate it in chemical environments, a day, a night, how to fix it. The maintenance guys get new equipment training, and the operators get new equipment training. And those ladies and men that get that training are proficient, and it ends with a culminating event and outbreathe. So that's how we do it in the Army. And in fairness, there is some challenge there. So if you didn't get the training in the schoolhouse and you move to the unit that just got the new training, it's the responsibility of the leaders that are located there to bring the new soldiers up to speed on the equipment. And it works very well for us. So I'm pretty confident that we're not going to outpace. First of all, you can't outpace an American soldier, right? But this is really a good, tried and tested system that we have. Glenn, am I forgetting anything?
Yeah, so the thing I would add is key to us being able to deliver something that's usable is early soldier involvement in the development process, right? There is no substitute for getting the end user in early to tell you not only how is he or she going to use it best, but how they intend to operate it. And it's one of the things we've learned. I mean, we call them soldier touch points now. I mean, we used to call them user juries that we've done for a while, but we're getting a lot more focus on it. And it's so critically important. And the environment you do it in really matters. And I'll give you an example. We were putting a display and a command and control system on one of our platforms. And we started with the way we traditionally do it. We handed a spec to an engineer that was written here in the program office. And the engineer at the company, just came up with a design and checked all the boxes and built it. And we took it out to the field. And of course, we got really bad feedback. So we said, oh, well, we should have had the soldier involved in the development process. And so we took some soldiers and we brought them here to Michigan, and they sat them down with the engineers and talked through the problem and came up with a new list of requirements they had to meet. And then the engineers went off and did the design and took it out and gave that to the soldiers and said, yeah, you're still not there. Because the problem was the engineers didn't have enough context. So the third time around, and it's a shame it took us 3 iterations, we took the engineers to the soldiers and we stuffed them in the back of the vehicle with the guys who were operating the system who could show them, this is what I'm doing every day. These are the functions that I perform more often. These are the functions that I perform less often. And the engineers were then able to go, okay, I understand now. You give them this sort of requirements checklist, but now I have the context. And so the third design that I came up with was much more acceptable. So that's being baked into everything we do. There's regular soldier touch points and experiments. General Coffman's team is really leading this to make sure that as early as possible, we're getting those refined products of how it's used and what are the user interfaces. How do you want the display laid out? What's a hard button? What's a soft button? When does the touch screen make sense versus, I want a hand control? Is it a traditional hand joystick, or is it the, Xbox based? What are soldiers going to be familiar with? And let them tell us and drive how they operate with the system. You don't need a manual to operate your cell phone, right? We ought to be getting to that point with, military equipment. Yeah, more complex, more safety issues, that sort of thing. But it's only early involvement with the end user that's going to drive us there.
I think if you grab 10 soldiers from 10 different units and ask them the same question, you often get a lot of different answers. So if you mentioned experiments in your explanation there. Do you ever, General Coffman, perhaps you can answer this. Besides asking soldiers, what they think, where things should go, and what they're trying to perform and accomplish, do you take measurements of their performance to see if it matches up with their desires on how things should be built?
Yeah, so it's a great point. There's two things. So I've been to soldier experiments where the people that were conducting the experiments or the soldier touch point were not trained. And so when the unit comes and it's not trained on the task you're asking them to do, then it's garbage in, garbage out. And then in that case, we had to go back and we had to ensure that there was a training level that was sufficient, and then gave them the equipment to see did they perform better with the new equipment or worse. So that's really a big part of it. And then the other instance is when they are trained, how do you make sure that they understand how to operate the equipment sufficiently so that the data you're getting out means that they are not only they're trained in the warrior task and drill, they're trained on the technology, and then you can deduce something that is absolutely, truth or better or worse for our soldiers. And then like none of us fell off the turnip truck yesterday either. You've got, you talk to 15 non-commissioned officers, you get 15 different answers. But look, I've got young sergeants on my team too, right? And so that are mature, that are dealing with this every day, and they can kind of rack and stack those comments of, hey, these are things that make a lot of sense to us. I mean, we put an incredible amount of faith and trust in our non-commissioned officer corps for a reason, because they are really smart, really focused, and give us great feedback, both in the unit, FORSCOM units, and then those we put into advisory positions.
Yeah, it's amazing how good the NCOs are and how well trained they are and how they take care of their soldiers. And when you do have these experiments and these touch points, do you find that they are getting the feedback to them through the changes that they've suggested? Are we taking their input seriously and making those changes? And can you give an example of where you've seen that?
Yeah, so I think the frustrating part, if I was to read the mind of the soldiers, the frustrating part is I want that now, and you're telling me I can't get it for 7 years. Okay, so that there's a little bit of frustration there. But look, I'll give you a perfect example. We've got soldier experiment number 2 for the robots coming up. Okay, and we're moving from platoon operations up to company operations. We have purpose-built robots, and we went out to Fort Carson, Colorado last year, and we did platoon operations. All of that information that we gathered, they did survey after survey, what they want to fix, what they want to improve, what they want to get rid of. And we made a list. And then I had all the engineers, and they had to account for all those comments. We are going to change it for the second experiment. We are not. And then I had to approve that. And so it's okay if we choose not to follow someone's recommendation. Right? It's disagreement is not disrespect. Right? I'm not disrespecting you. I just don't agree. But the important thing is that it's a conscious decision. Where in the past, hell, we didn't even, in early procurement days, we just said, hey, we'll give you what you need, soldier. Now we understand that everything's going to end up in their hands, and we better listen up front.
Do you find that sometimes soldiers don't know what they can ask for, and how do you account for the technology advances that they may be able to have and show them more than they might be expecting?
Yeah, it's all on the question. I used to like that show West Wing, and they would remember they'd bring in a pollster, and she would say, "You're asking the wrong question," and it's opening question. How would you make it better, rather than do you like this knob? So that's we do not suffer for a lack of imagination in the Army, and soldiers, they're so quick. And they provide us great, like, well, what about this? And how would you do this? But what's even better is, Glenn and I'll think we're old guys. We're sitting around. We're like, wow, they absolutely need this pen, and so they can write with. And the soldier will say, oh yeah, I can write with it. But what I'm really going to do is I'm going to put it in this problem that I have, and it's going to fix this. It's not because it can write. It's because it's this exact shape, and that's what they've been looking for. And they're going to use it this way, and they're going to use it in unexpected ways that Glenn and I wouldn't think of, because we don't do that task on a daily basis. So I don't know, Glenn, anything I'm forgetting?
Yeah, well, I think a good TTP that the Army's coming to is trying to get units that have continuity with the experimentation of activity. And so we did it when we put 30mm cannons on strikers in the combat vehicle arena. We're going to be doing it with our extended range cannon artillery that Army's going to select that unit, announce that unit here shortly. I think it's going to get the first of those systems, and they're going to carry with it. The Army's doing it with integrated air and missile defense. There's a Patriot unit that's been dedicated to developing the IAMD software. And that continuity of thought matters, because when you get the sergeant who says, hey, this is what's wrong with it, and they have the dialogue with the technical folks about what's possible and what's not possible, and he understands what the trade-offs are. And then, okay, here's your solution. You come back and it's the same guy. He knows, okay, I know why you made the change, and now I can grow from there. We've had that problem in the past where we've gone to one unit and they've given us a set of feedback, and it's like, okay, paint it green, and then you go to the next unit and he goes, he wasn't involved the first time, right? No, we've decided to paint it tan. You go to the third unit, no, paint it back to green. So continuity thought and early development is really helpful for us, and the Army started to do that with its major systems in a very sort of deliberately chosen manner. I think that's going to help us move faster.
Foundationally, you're both responsible for a vast and technologically complex set of vehicles, and industry is certainly constantly wanting to work with the Army. What are some messages that you would like to give industry on what your expectations are as they evolve in sort of this new near-peer focus again?
Yeah, from the requirement side, well, I guess, and I've never said this publicly before, but you know, when I drive a car off the lot that I just bought, I'm not expecting that thing to break down. It's so much so that it's under warranty for several years, because there's confidence that this thing is going to be reliable. But for whatever reason, when we do complex, heavy machinery, that we're kind of looking for an 80 to 90%. I'd like to see them find ways to push that higher and help us logistically, because that's really the bill, right? I mean, when you have a vehicle for 40 years, the sustainment costs of that are just crushing our tax dollars. So more reliability is what I would say just off the bat. But Glenn?
Yeah, so one, stay engaged with us, because we don't know what we don't know. Don't be afraid, especially early on, to kind of push back, because we may have written a requirement or a specification or be talking about something in a certain way that makes sense to us, and we don't see the better way to do it, because that's just how we've always done it. And often the challenges are buried deep down in details of specifications. They're not immediately obvious, but if you can call those to our attention, we'll find out that, yeah, I don't actually need to specify that, because, hey, there's an industry best practice that's going to apply here, and we don't catch everything. So early pushback is good. But then when we do get out there, don't be afraid to compete. And then once you win the contract, hey, you got to help us make it sustainable for the life cycle. And look, we need to be able to spare it and repair it, and that probably means subsequent competitive activities for spares. So along the way, if you're continuing to add value to your product and you're making it easier and cheaper for us to maintain and operate, it's going to stay in the field that much longer and generate that many more opportunities to support. But as systems get more complex, if we're not exerting a concerted effort to make them easier and cheaper to maintain for the long term, well, then we can afford fewer new capabilities, and our systems will not stay relevant the way we want them to.
So for the last 20-ish years, we've been in desert and mountainous environments, and now, of course, we've been all over the world as well. But the public feels like we've been developing equipment that is really for a couple of different types of environments. What's the message to industry for the fact that we're looking for equipment that can be used anywhere in the world?
Yeah. Well, you know, we got some unwritten rules. We don't play home games, and we have to be worldwide responsive. And so we have to be able to fight no matter where our nation needs us. We got to be able to move from fort to port and port to port and get on the ground and fight. Look, our elected officials have said that China is our pacing threat. Over 50% of the world's population lives in Asia, in the Pacific AOR. There is huge landmass. There's jungles, there's mountains, there's deserts, there's huge cities. All of these require armored vehicles to fight and win. Okay, you want to be able to hold terrain. Then you're going to need vehicles to get your infantrymen on and your infantry women on the ground. So we cannot look at this myopically. We have to be able to fight anywhere on this earth, and the United States Army is the only ground force with tanks. Only ground force with Bradleys. Okay, we want to replace that Bradley with something way better so that we can fight worldwide and win.
That sounds like a great place to finish up. General Dean, any last comments?
Oh, thanks. It's been a great opportunity to participate in the panel. I hope the folks who are listening are taking some good ideas away from it. I look forward to future engagement.
General Coffman, any last comments?
No, thank you, and thank you for this opportunity. It's been great.
Yeah, I really appreciate taking the time. I really enjoy working with you both, and I look forward to seeing where we go with this next combat vehicle and with your robotics experiments, and taking that into the next stage of autonomy, as we are interested in seeing how far we can push that technology. And that's, I think you both talked about that we're not standing still. We're pushing as hard as we can within constraints, but also understanding that technology is not boundless and they can't wave your hands and just create it, that it takes time to get there. You two have obviously spent a great deal of your life helping the Army and had so many experiences. And I don't think we could be in better hands with anyone else. We could be in the same hands with many of our GOs in the Army, and you two are great representatives and are doing a great job in the ground combat world. Really appreciate you taking the time. Really appreciate having two such qualified individuals in the position that you're in, where you're responsible for such a large portfolio in ground combat vehicles. I don't think we're in better hands. So it's just a real pleasure to have talked to you today, and I wish you all the best. And a message to industry, which is, we really do want you to be working with us. We want you to be giving us your best ideas, and we want to create the environment under which you feel that you're being treated fairly and that we're being treated fairly. And if we get there, then I don't think there's anything that can stop us. So thank you again. Have a great afternoon, and that's it. Have a great afternoon, and that's it.